Year 7, today we are doing what is possibly a little bit more tricky for us, and we're going to have to think carefully about it. We're going to build on our work yesterday with prime and composite numbers, and then try and do a factor tree to write a number as a product of its prime factors. You've probably never seen a factor tree before, that's okay, I'm going to show you. So we've got 3 examples here of questions. Write the following as a product of their prime factors. Actually, question 3 will be a bit different. So question 1, it says, write 24 as a product of its prime factors. Now, I don't expect you know this straight away. So, let me show you how to get there. You write the number 24. What you need to do next is think of 2 numbers that multiply together to give 24. You don't choose 1 and 24, all right? You choose 2 other numbers. Let's, for example, choose 4 and 6. So we write them underneath like this. Okay? From there, we want to think of what 2 numbers multiply together to give 4. Well, it's 2 and 2. What 2 numbers multiply together to give 6? 2 and 3, isn't it? Yeah. Now, each of those is now a prime number. So we could actually say 24 is equal to 2 times 2 times 2 times 3. That is 24 as a product of its prime factors. That's how we do that one. I'm going to do 648 in a moment. Make sure you've got this down because I'm about to rub it out. Question.
So it's basically 2 cubed times 3.
If you wanted to write it in index notation, you could, yes, like that. However, at the moment, I'm just saying write it like this. All right, let me do the next one.
But Mr. Clark, isn't 1 also?
No, because 1's not a prime number, remember. So remember that.
No.
So question 2, let's have a go at 648. Oh, that's a bit tricky, isn't it? I don't know straight away what are the 2 prime, or the prime factors of 648. But I do know that it's at least divisible by 2. Alright? So, let's write 2 out there. And if I think of 648 divided by 2, I know it's going to be 300 and something. And it's actually, what do you think?
324.
324, good. Now 2 is a prime number. I don't need to go any further with that, so I can just leave 2 to go down there by itself. 324, again, it's an even number, so 2 must be a factor. So let's write 2. What's 324 divided by 2? 162. Now I partly know that. I hope I've got it right. Okay? But you might take a little bit longer. But that's what you're doing. So we keep going. 2 again will stay as 2. That 2 will stay as 2. 162 divided by 2 is 81 this time. Hopefully now you know your times tables and you actually recognise 81 and we can get there a bit quicker. You should hopefully know that 9 times 9 is 81. We leave the 2 as 2, keep leaving it as 2. What are the prime factors of 9?
3.
Yep, so it's 3 and 3, isn't it? Oh, there's only 1, 2 there. Let me get that right. 2, 2, and 2. So therefore, we can write it, and remember you've got to answer the question. Don't just draw the factor tree. Actually write the answer. 648 is equal to 3 times 3 times 3 times 3 times 2 times 2 times 2. Now, as was said earlier, you could write this using index notation. 3 to the power of 4 times 2 to the power of 3. Make sure you've got this down. That takes a bit more working. But we have just followed the same process to get there. Okay. I want to rub that one out. I'll leave the number down the bottom so you can see it, because I want to do this last question, question 3. Because question 3 is a bit different. I put it in the wrong spot, but it's right, we can work with it. Really, what we're being asked for is the square root of 196. And we can use factor trees to find that. Let me show you how. 196, we know, for example, that can be divided by 2. 196 divided by 2 is 98. 98 divided by 2, 49 and 2. And we keep that 2 going down. We also hopefully know by now, we know our times table, 7 times 7 is 49. Now when I'm finding the square root, what I'm trying to find is the number multiplied by itself that gives this answer. So 196 is equal to 7 times 7 times 2 times 2. But what we know about multiplication laws, we can also write this as 7 times 2 times 7 times 2. Put brackets around, and hopefully you can see it's 14 times 14. So I don't need to know the square root of 196 is 14. I can get there using my factor tree. As a result, my final answer, square root of 196 is equal to 14. So hopefully you can see how I can use my factor tree, not just to write it as a multiple of prime factors, but also to find the square root of a number. Could do the same with the cube root, whatever it is. Prime factor trees, it looks straightforward, work carefully, and you should be able to get there. Why don't we get on and do some work?